Hello YouTubers, Dave out in Pennsylvania, USA. I just completed a 75 cycle run of charge-discharge with the deep-eutectic E-load device. Prior videos I illustrated its use, demonstrated its use. So this ran 75 cycles of charge-discharge. Here are my parameters. I charged up at constant voltage, 750 milliamps, cut off 4.10 volts, trickle current down to 0.25 amps. 1 minute wait period, and then a discharge at constant current, 750 milliamps, cut off 3.00 volts, wait time 1 minute. Using a 3.7 volt lithium ion rechargeable cell in the circuit, along with the material that I'm studying. I'll call it yarn or twine, helical shaped cord, commercially available. I've used it as is, dry conditions, no treatment with alcohol, no soap and water, right as received. And I put it inside of a dummy AA. These are available on eBay, Amazon. I use both this type, and actually I like these other ones. They just work out better for the work I do. Both on Amazon or eBay. Dummy AAs. The yellow ones have a wire inside connecting both electrodes, which I remove or cut. This does not. You can see this one, I cut the wire out and the yarn is in there packed in. I check for continuity, of course, before putting it into the circuit with the lithium ion cell. After 75 runs, the unit with the yarn was 5.091 grams, and after 75 cycles of charge-discharge, 5.089, so I lost, my math is correct, 2 milligrams. Not completely sealed. There are small vents. As you can see, there's one, and there's the other. For safety, particularly when I do a wet run with a deep-eutectic solvent and a lithium electrolyte, lithium salt, usually lithium tetrafluoroborate electrolyte in choline chloride, urea, a 1:4 mole ratio respectively. That's an easily prepared deep-eutectic solvent. But this is a dry run. Now, after I pack the yarn in, I actually put it into, of course, a carriage, a AA carriage, and I take a cotter pin and I solder in the leads, and I put that right into the negative, the black, so it's in the circuit with the lithium ion cell. Now, why do you use the lithium ion cell? Well, because I want to be able to charge and discharge up as high as 4.1 volts. And these lithium ions can be, according to the manufacturer, charged up to 4.2 volts with a cutoff of 2.75 volts. So to play it safe, I go 4.1 volts to 3.0. And I want the graphite material, in this case the yarn, to be in the circuit, so I can see the effect of charge-discharge. And then we will scan these with the electron microscope and look for small but possibly significant changes. So the dry run, you can see completed. To my website, I will put the data and this graph, and performed pretty well. Here are the, and I'll put these in the write-up, capacities for the charge constant voltage, and discharge, constant current. And if you can see my handwriting there, I've selected cycles 5, 15, 25, all the way up to 70, and then 75, taking data points pretty good. We go from 0.054 versus 0.056 for cycle 5. Then it's running through, and after 75, it's 0.052 versus 0.053. So there's very good consistency, and that's well and fine for a dry run. Next, I'll add my DES and electrolyte solution, and then start bringing it up well above the potential of 2.7 volts, normally found in E supercaps, electrolytic supercaps. If it has water, then you're down around 1.1 volts. If you have an organic solvent like dimethylformamide or one of the alkyl carbonates, by industry agreement, convention, usually they go to 2.7 volts. Here's a supercap commercial, and I have had good luck with these green caps. 2.7 volts, 100 farads capacitance. And I did a check on the capacitance, and when I bought this, I was getting first estimate about 93 farads, so rough approximation was pretty good. Other soup caps I've bought on Amazon were dummies, and I had to return them. I've had good luck with this green cap for reference work. So we're working with electrodes, graphitic materials, both felt and yarn, and we will nickel plate, nickel cobalt alloy plate. We will oxidize the graphite with oxidizing agents like commercially available Oxone, a registered trademark used in swimming pools. Pretty good oxidizing agent. And we attempt to modify the surface of the yarn before and after, and then do a dry run and then a wet with DES electrolyte. So anyway, I'll put these numbers up, and as we go along, I will start to upload videos on different conditions of graphite pre-treatment before evaluation. So we like to look at the graphitic materials as electrodes, and then we assemble benchtop supercaps for testing. But I want to see how the graphitic materials perform with a selected DES electrolyte. We're also using lithium bromide. I will disclose that in a future upload. And getting lithium bromide to dissolve in some of the DESs pretty readily, which could be important. But this will conclude this YouTube video, and I will put my website link down so you could start to get the data here. Thanks for watching. We'll keep you posted. Bye for now.